my terrible bone-conducting headphone mic. There, I'm like, okay, I'm gonna actually go ahead and invest in.
Oh wait, my jabber's broken. I have to refresh. 1 moment.
Bye, Martin. Hopefully, we'll see him again.
Yeah, I think so. Quite soon. So, yeah, I'm just chatting a bit here so that everyone who joins actually have something to listen to, so they know that things are working. So that's my primary thing of actually keeping me busy here. But we'll very soon start as soon as Martin has rejoined. So, okay. Are you ready to go?
Yeah,
Martin?
your jabber might not have been problematic, Martin. It may have just been empty.
Yeah. Well, either way, it's working now. So let's get started. You want to start, Magnus, or should I?
I can start. So, welcome everyone to Tsvarea, the meeting. So I'm Magnus Westlund, and my co-AD Martin is on picture too. So, and I asked him to. So the note well applies also to this meeting, and so if you don't know it, read up on this, the BCPs, etc., about code of conduct, anti-harassment procedures, copyright, patents, all these things, and our standardization process. So this meeting will be fairly straightforward. The session is recorded. The note well is shown. Blue sheets automatically generated. I'm not certain that we need a jabber scribe. Then we will have an overview, and we will have an update from tabs, and then open mics for this session. Have you set up any note takers? That I guess is not done yet. That we failed on. So if you have any volunteers who can help writing notes, they don't need to be detailed.
Taking job all meeting.
Thank you, Maria.
Volunteer. Thank you.
Okay, so any agenda bashing? I hope not. You get 20 minutes to speak your minds to us. So, okay, let's go up. So, a overview of where we are in the area in general. Go ahead, Martin, talk about Alto.
Yeah, so we have a new chair, Chin Wu. I don't know if he's in the room today, but he's chaired a number of other groups before. He's been involved in Alto for a number of years, and he's taking over. The two existing chairs are going to step down over the next few months as they complete their milestones. We're almost done with the milestones, and we're going to recharter soon. And most of this week's meeting was about that rechartering, and there's a bunch of great ideas. We just have to narrow them down. I guess I'll just talk through all my stuff. See anything else of note really here? You can kind of see what it says, and yeah, I mean, Alto is actually probably the one that's had the most interesting transition of really all the working groups that I oversee. So off to you, Magnus.
Yes. So first of all, in DTN, we have a new working group chair in Bahrain. I really want to thank Mark Blanchette, who has been since the working group was chartered, and very much a large applause, I would say, for him for doing this work for long. They are finishing up the core documents. We're really trying to get through the ISD with the first set of core documents, and then I hope we'll see more continued. And in NFS v4 is not meeting this week. They're planning an interim meeting in a few weeks, and they have recharted to include RDMA maintenance since last meeting. Quick, it's big news. The Westra's ended IETF last call early this week. They had a interim on multi-paths, and that discussion is kind of ongoing, but there's a direction here for enabling experimentation discussion, but we'll see how that continue. certainly in the working group. PAPS continued series of interim meetings, and they're very close to having an interface document. And that's why we're having reminding people here and maybe take a look at this as they're finishing up their first set of interface API specifications, or not API, but what the interface looks like. I hope Stram will be done sometimes, but it's not making a lot of progress. But otherwise, it's one final document before that working group can close. So, Martin, do you want to take the question for Lars publicly on the audio?
Oh yeah, so Lars on Jabber asked what Alto was recharting for. There were actually 5 different themes that came up in the discussion, and I've told them to try to reach consensus on the subset of those. There was actually it's not a large group by any means, but there was quite a lot of energy around a lot of these ideas. If people are interested, the agenda materials have like a lot more information about these concepts. And Lars is in the queue.
Yeah, hey, sorry, I don't want to drag this out. I was a little bit surprised because so has Alto, I have not followed it in a while. Has it gotten deployment now?
That's my understanding, yes.
Okay, that answers my question, because without that, I would question if more work is needed. But if there are deployments, it's a different story. Thanks.
I'm not an expert on this, but I believe, especially in China, it's gotten quite a bit of at least some deployment.
Okay, then we move on. So Martin, do you take this?
Okay, so we had a very fruitful, or at least the RC editor had a very fruitful 4 months of processing our documents, and a whole bunch of the editor queue has gotten a lot smaller. And as you can see, we got 4 things out of the ISG in this cycle. You can see them, and then there's some other stuff that's sitting around. But cluster 238 is winding its way towards conclusion. So we think a lot of that old RMCat stuff is going to pop pretty soon, and that'll be exciting.
Yep, that's good. And in general, I mean, for general information, the fact that cluster 238 is winding down will actually reduce the time it takes for the RC editor to process documents that's going to the queue, because they're actually draining their queue, which was grown by, for example, cluster 238, but also the transition to version 3 format. So, and I have to thank you. One of these is that actually the packetization layer path MTU discovery RFC is actually is using some of these features for V3, and it's one of these early spearheads that actually used the format for some of the new things like SVD graphics and things like that. So it was good, interesting to see that go through. So, and actually, you should consider adopting some of the V3 features for getting better documents that uses this. So the Tsvarea review team has continued to review documents that the triage thinks is suitable to be needing transport reviews, and we will thank you all of the reviewers that done something. You will see those that has reviewed 1 or more documents here, as noted how many they've done. It's still not a high load to be in this review team, so anything to add, Martin?
Yeah, just as always, I think that these statistics show that this is not a particularly onerous thing to volunteer for, and I think it really expands your horizons at IETF, and I'd really encourage people to consider joining the art.
Yes. And we have, I'm stepping down in March, and we have 3 TSV AD candidates, and today is the last day to provide input to the NomCom. So if you haven't done so already, please provide input on the transport AD candidates.
Some of whom are electioneering right now.
So, but yes, it's David Skenazy, Saedman Zakir, and Ken Kao, which is the candidates. So please provide the input. Yes, you have the whole of Friday, and I think if you were in the plenary, Barbara said they were going to be open probably weekend out before they closed it. So, but
well she said she would turn it off on her Saturday, which I assume is somewhere in America.
Yeah.
So you pretty much have all of Friday, no matter where you live.
Yeah.
But just do it now.
Yeah. And help the Nomcom make a good choice. So, but we're grateful to see that we have 3 candidates, and that's very good. And I think that was the last slide from us, and therefore we will switch to Brian, and then we'll come back with open mic afterwards. So.
Yeah. So if I can introduce this, so I am a recent arrival at the TAPS working group, and I am now super duper interested in it as an individual contributor. I think it's very interesting work that has a lot of applications at my job and just as a transport guy. It is also kind of inaccessible. Their meetings are kind of GitHub operations for the most part, and they generally don't meet at big IETFs. They're all interims. So yeah, I invited Brian to give this talk just so people can get in touch with it and hopefully get some people interested to go read the drafts and start participating, because I think it's really interesting work. So Brian, go ahead.
Thank you, Martin. I hope I can make this more accessible. That's actually kind of a that's a tall order, but we'll see. We'll see if this unconfuses things a little bit. So hi. Actually, we can just sort of skip this slide. This is Bangkok, where we are not. But Martin did a good introduction, so I'll just go straight into the content. So it's really kind of hard to understand how we got to be the working group we are without understanding sort of the initial case for TAPS. And there are sort of 3 observations here. One of them is that there's a hard binding between transport behaviors and concrete protocols, right? Like, so the sockets API basically works pretty well for SockStream and SockDgram. SockSeek packet was sort of backported onto it, but in order to actually use SCTP, for example, you need to use the SCTP API. So, you know, if all you have is sockets, all you're ever going to be able to deploy is UDP and TCP, just because, you know, you have no API to actually select it. There's also the problem that deployment of newer protocols, and you know, we're harping a lot on SCTP here because that was sort of the big sort of deployment pain that we remembered when we started this work in TAPS. You might have network conditions, right? You might be behind an app that doesn't know what SCTP is or how to deal with it. So you might want to be able to have the endpoint do some network sensing and figure out, okay, will SCTP work here or not, or will this transport work here or not? So a lot of this work was put together by the NEAT project, a FP7 or H2020. I think it was already H2020 by then, an EU-funded research project. And it really focused on this dynamic transport selection problem, right? Like, so how can we use information about what the OS supports and what the you know, what the network can support, and use that to dynamically select the protocol. So that was really the focus of the NEAT project. And as we started working on this, we realized that dynamic selection is only half the battle, right? Like, so if I have an application that is expecting you know, sequential streams in a single sequential stream per connection object, and then my OS tells me, oh, but you can use SCTP. Cool, I'm just going to use SCTP to give me TCP-like service. So unless we have an abstraction that sits on top of sort of the union of all supported transport behavior, and allows us to select, you know, what we need and to emulate what we can't get from the operating system in the network, then we're going to be constrained to the least common denominator. So there's work in a research project that I was involved in, PostSockets, and also work in Network.Framework from Apple that sort of, you know, tries to break this up. So the story so far. Next slide. So in 2014, we were chartered specifically for the dynamic transport selection problem, and only the dynamic transport selection problem. And we went off and did the homework of looking at the various transport layer behaviors that were available from IETF protocols in order to understand the basis of dynamic selection. Like, so what are all of the various different things you might want to choose based on, or that you might want to give an application? And this is when it became clear that we needed an abstract API. As we were getting into this, it's like, okay, great, but these behaviors are different enough that just putting them into the sockets model and hiding all of the goodness behind sock ops is not going to lead to application adoption of this. So a couple of years later, we started working on the groundwork for the abstract API. So this is the MinSet work and looking at sort of how various transports and how UDP can be split up into the categories that 8095 looked into. And then once we had that groundwork, I mean, you'll notice that like there's an 8303 and 8304 and an 8923. It took us a while to finally get MinSet published, but that is out since the last meeting. The work was mainly done a couple of years ago, though. Then we switched our attention in 2018 to actually looking at what this abstract API would look at. And this is split into 3 different documents. So this is the Brian tries to make it accessible. There's the architecture document, which sets out the assumptions that we make about the problem that we're trying to solve, right? Like, so it says there's this, we assume that there's this thing called a transport services implementation. This transport services implementation provides an API up to the application and has some machinery for doing the dynamic selection and for dynamic, so candidate racing. So like think about happy eyeballs, but happy eyeballs across all of the different dimensions that you might care about with respect to like which protocols you're going to use. And then we have the interface on top of that. So there's the architecture is what the transport services is. The interface is what is the interface that the application uses to use the transport layer when using a transport services system. The interface document is where we actually describe the details of this abstract API. And this has several sort of concepts. There's a concept of a connection. There's a concept of a pre-connection, which is all of the information that you need in order to create a connection. It supports the concept of rendezvous. So like the ability not just to say, I'm going to listen and initiate, but have 2 endpoints find each other. So this would be sort of in an ice-like environment. And then it supports sort of message-oriented and stream-oriented interactions. It supports message framing. We'll get into the details of that in a minute. And then the implementation document is where we get into the nitty-gritty details of here are things that we here are things that as we have gained implementation experience with building systems in TAPS that you as an implementer of TAPS should probably look out for, right? Like, so it's kind of an implementation notes and guidelines document. So to the are there implementations question, we'll answer this later, but like around the same time that we started to work on the architecture interface and implementation documents, network.framework, so Apple's formerly internal, now published API that is extremely TAPS-like, was announced at WWDC. So on the next slide, the next 2 slides, we're gonna like look at the sort of the different architecture, the basic difference between sockets and TAPS. So next slide. This is a picture of how interactions work between the application and the network in the sockets API, right? We have a stream API and a datagram API. They use mainly the same calls, like you have like, write versus send and send message. But for the most part, using mainly the same calls, but they behave differently based on what the struct sock. It's been a while since I've used sockets. The structure underneath, like, basically is a union structure that gives you markedly different behavior based on which you select. The stream API generally binds to a TCP protocol stack. The datagram API binds to a UDP protocol stack. I could have put like the seek packet API and have it bind to an SCTP protocol stack. But like there's a different API and a different application interaction model for each of these things. There's also another part of the sockets interface, which is extremely important for establishing connections in Rendezvous, and that's the stub resolver. And the stub resolver is a thing that the application has to interact with directly. So like if I have a name and I want to turn it into an address that I can actually use to bind or connect to something, I need to do the resolution myself. And this has sort of the upside if the application has complete control over when resolution happens, which is, you know, good in certain cases when you might not want to leak information if you don't know that you're on a network with queue name minimization. But it also means that the operating system or the platform that is providing the transport services doesn't have enough information to be able to do sort of like good racing, right? Like, so you can't say, okay, I'm going to defer the lookup of the thing that I don't need, or more importantly, if the transport service implementations thinks it might need information in the future, it can actually go ahead and start queuing up these resolutions in order to parallelize things. Let's go to the next slide, which is somewhat more complicated, and I think this is the diagram that that might have scared Martin off when he first landed in TAPS. This is the transport services architecture. Up at the top, we still have the application, and it's essentially talking to the transport services interface. So this is the thing that's defined in the API document. There are sort of 4 different phases of this lifecycle, which we'll get to later in the talk. There's this pre-establishment phase where the application gives information about its requirements and expectations to the transport services interface. And this is where the transport service interface gets the information it needs in order to be able to select a path and a protocol stack. Then from a pre-connection, you can go off and create a connection. The connection is the object over which all of the data transfer happens. The data transfer is event-driven, so basically you can say to the connection, hi, I'm willing to receive this many messages with this many bytes, and it will send those back up to you asynchronously, so you're not necessarily polling. The transport service interface itself also throws off these asynchronous events as things about the available stacks. For example, your connectivity may have changed. Now you're on an IPv6 network. Now you have IPv6 stacks. As these things change, those events can come back up to the application as well. Inside the transport system implementation, there are a few sort of like long-lived things. There's policy, which allows the tweaking of the selection of protocol stacks, like, you know, saying, hey, I prefer IPv6, so I'm going to actually do happy eyeballs, and I'm going to give it a 20 millisecond head start, for example. Or, you know, on this network, UDP is disallowed unless it goes through this proxy. These sorts of things are in the policy. These are mainly implementation specific, but we allow for it. There's also a state cache. So the transport system can learn which bits of the you know, which networks or which connections or which paths might support or not support certain things, and can use that to adjust the racing. And then underneath that, all of that, there are sort of the concrete implementations of the protocol stacks. You'll notice in this diagram, we did not draw sort of like the kernel user space boundary. In the previous diagram, the kernel user space boundary is usually sort of like right there between the application. Application has a little bit of a library, but it basically all turns it to syscalls. The TAPS interface could be implemented, you know, that kernel user space boundary could be sort of above the transport service interface. It could be between the transport service interface and the implementation. So you have the interface, which does some of this state management, runs in user space, but is actually using racing in the kernel, or it could all be in user space on top of. I mean, you could implement this on top of any syscall interface. There are sort of multiple different ways to do that, and we're explicitly agnostic about it. Next slide. So just like sort of this is the sales slide. These are the features of the abstract interface. I think I've gone through most of these. So it's designed specifically to allow for optimization and parallelization, right? This idea of having a pre-connection phase followed by a connection phase means, so once the pre-connection set up, the transport services implementation can actually go and do whatever measurements it needs to in order to figure out, you know, what it's going to do when a connection finally happens. Explicitly here, resolution. So this, you know, the thing that happens is stub resolver and connection are not explicitly separate. You can pass an endpoint into this API at whatever layer of abstraction you have a resolver for, and it can go off and resolve that for you in the background. There is also control over, you can tell the systems in the API explicitly, please defer any resolution until as late as possible, just to minimize information that might radiate out of the resolution process. Obviously, if you put this on top of something like dot or do, this is it's less important for the application or the other policy to be able to control this, but we wanted to have the knob. Sending and receiving are both asynchronous and event-driven. The connection interface is also designed to abstract away multi-streaming and multi-path protocols, right? Like, so you can have, if you end up with a multi-streaming protocol like QUIC or SCTP underneath, like in your transport, as your transport stack that gets selected, then there's the idea of basically taking a connection and cloning it. It's kind of like fork in Unix. And if you clone a multi-streamed protocol, you actually end up now with two streams inside the same protocol. But this also allows you to do to have applications that do this cloning that says, hey, I want a connection to the same endpoint, to the same application, please make that happen. And if you end up selecting a protocol that's not multi-streaming, it'll just create multiple flows. In terms of the amount of time we've spent on it, I'd say possibly the trickiest and most important, and I'll say trickiest, it's not the most important feature. We really wanted to make sure that like taps would be usable in a world where only one endpoint is using taps, because otherwise, like, requiring coordinated deployment of some system is basically, you're talking about not building a protocol selection engine, but a new protocol. We didn't want to do that. We wanted a protocol selection engine. So specifically, if we end up in a situation where you have one side that is trying to provide a message-oriented service to the application, the other side is just straight TCP, and it's going to do its own deframing inside the application. We provide for the ability to push a framer, which is basically the thing that turns a stream of messages into a stream of bytes, and a deframer, which is a thing that turns a stream of bytes back into a stream of messages, which you can asynchronously pop up to the application. We can push that from the application down into the transport service. So the application basically gets this message-oriented thing, even if it's not running on top of a message boundary preserving protocol stack. Next slide. So, like, the way that, to make this a little bit more concrete, let's say that you're on a multiply connected device that has these 5 possible candidate protocol stacks. We can either run UDP over V4 over Ethernet, or TCP over V6 over Ethernet, or SCP over TTLS over UDP over V6 over Ethernet, or QUIC over V6 over cellular, or TCP over V4 over LTE. These selection properties up at the top are things that the application could then say that it wants to prefer or require or avoid or prohibit. And based on the set of things, the constraints that the application passes down, it'll eliminate some of these candidate protocol stacks from a possible connection, right? So, you know, if I'm looking for fixed interfaces, right, I don't want to run on LTE because, you know, I'm assuming that that's going to cost me more. Well, then I'm going to eliminate all the LTE, the stacks with LTE at layer 2. If I need a protocol that's explicitly multi-streaming, because for performance reasons, I'm going to clone a whole bunch of connections and I know I don't want to have flow explosion, well, that'll only allow me to select SCTP and QUIC, and so on. There's a gigantic list of these in the document. That's actually another one of the things. It's a little, can be a little intimidating at the beginning, but these are basically just, you know, they all fit into this framework of, I have some connection dimensions, and I'd like to use those to prune the set of possible candidate protocol stacks. Next slide. I think there's one more pretty picture. Yeah, so to get into a little bit more detail on how we create connections. So there are these sort of, these 3 phases, sort of pre-established, established, and terminated. I take, you know, information about the local endpoint, which is not just, you know, which addresses I want to possibly use as on my local addresses, but also information about my endpoint identity if I'm using a protocol that might require identity information. The remote endpoint, which is who I want to connect to, the transport properties, which is this sort of set of things that allow me to select a candidate protocol stack, and my security parameters, which are information that just gets passed into the security layer protocols that would be selected. This is the security parameters are special in TAPS because it turns out there are very, very, very few times that you might want to race based on a security protocol, because you don't want to end up in a situation where you actually downgrade attack yourself, right? Like, so a lot of transport protocols provide equivalent services or services that can be emulated by the system over equivalent stacks. This is not the case with security protocols, right? Like TLS 1.3 has different properties than TLS 1.1, for example. So the security parameters are kind of special, and we have a whole document about this. It was one of the ones that was just published, if I recall correctly. So you can either take a pre-connection and initiate it, in which case it's like an active open, or you can listen it, in which case it's a passive open. And the transport properties then turn into the set of bound bound listening sockets down underneath the system. When you initiate, you get a callback when the connection is ready. It's a connection ready event. And when you're listening, you get a callback or an event when the connection is received. And then you get a connection that you can transfer data on. And then there's basically two ways to end up terminated. There's either close, which is an orderly shutdown of the connection, or there's an abort, which is boop, throw my hands up and stop, right? Like, so these are like fin versus reset in TCP land. Next slide. So why, like, if you look at the document, you'll see, you know, a lot of stuff that looks kind of like pseudocode. Or the interface document, you'll see a lot of the stuff that looks kind of like pseudocode. You know, why is this an abstract interface? Why isn't this something more like the SCTP API, which is actually defined in terms of POSIX? And there's a couple of reasons for this, but mainly it's because Swift versus Haskell versus Rust versus whatnot is not much fun to discuss in the mic line. I did see Lucas ask a question about Rust, which we can talk about when I'm done here. But we're not in the business in the IETF of trying to change programming language idioms. And if we want to see something like this adopted, we want to have the general shape of the API be the same, but we want to fit it into the programming language idioms. Like, we had a student at ETH, back when I was at ETH, who implemented a TAP system for multi-architecture. We were switching between the internet and Scion, so this future internet architecture based on TAPs. And the implementation that they came up with was explicitly didn't have a lot of the names as we have in the TAPS API. And I'm like, well, why is that? It's like, well, I wrote it in Go, and I want Go programmers to be able to use it, so everything has to be called dial, right? Like, so we don't want to be in the business of changing the idioms, but we do want to incentivize application development to be less synchronous, less imperative about how it uses the transport layer in order to free up our ability to deploy new transport protocols. And if we have something that is shaped like this, but with slightly different names, one, it means that we have this evolution ability on more platforms. Two, it also means that as developers use APIs that are very much shaped like this, it becomes easier to sort of port applications between them, or to build frameworks on top of different platforms that sort of can then run on top of TAPS. Mike, you're now required to write a TAPS implementation in Forth. I'm sorry, I don't make the rules. Cool. Next slide. Sorry, just looked at Jabber. So why do we, why do we need this, right? Like, so why do we actually need to have transport layer agility, right? Like, I thought this was the quick area. So if you look at all of the transport protocol features that we have in TAPS, the one that has, or the two that have not yet been pulled into Quick, but there's a lot of discussion about talking about them, is multipath. Sorry, John, I said multipath Quick. And partial reliability, even though there are certainly very easy hacks for doing partial reliability in Quick. So why do we need transport protocol agility if everything's going to be quick? I'd say there are There are a few reasons for this. One, like I tend to believe that like sort of the future, at least of the wire image of the transport layer, is going to be increasingly quick. The Quick working group has a slightly different philosophy about this than the TAPS working group, to put it mildly. Quick explicitly doesn't have a proper interface. There's a focus on the web. The implementations are tied to H3. The interface between the application and transport is kind of blurry, kind of internal. Like there are requirements for what that interface has to do. But if you look at the implementations of Quick, these things are bound pretty tightly to each other. And that's actually done for sort of like performance reasons. This is seen as a feature. We believe there's still quite a lot of value of having this abstract API. And of course, Quick could be one of the candidate stacks that lives underneath this. You could also have, WebSockets or web transport over H3 over Quick as one of the candidate stacks on this, right? Like, so it subsumes all of these things. So next slide, which I think is my last slide. So we're almost done. The drafts are there at github.com, IETF TAPS API drafts. Architecture has been close to completion for quite a while. We've basically been holding it, making sure that we don't find anything in the interface that invalidates some part of the architecture. Interface has, I think, 2 open issues on it that are ready for text. We just need to get people out of this working group meeting so they can go write text. Implementation is following close behind. 2 implementations that people in the working group have quite a bit of experience with are Apple's network.framework, and there's one that's looking at TAPS on top of Python async IO as a user space environment from so Max and Teresa and a couple of other people from FDINet. I think I've seen there was a few research grades implementations, one in Go. I've seen some work in Rust, someone actually trying to put this on top of Rust's async. I think Colin had a student that was doing that. But these are the 2 big ones that we know about. So, please come have a look. The architecture and interface will be going through last call and moving up soon. So this is kind of a speak now or, enjoy the results. But please do come by, and I hope that this makes TAPS less scary for those of you who have not been paying attention to it. So that I think we have a little bit of time for questions.
Oh, yeah, certainly. Brian, thanks for being funny. So the TAPS crew has been pretty good about running a Q&A and Jabber, but yes, we have plenty of time for comments. So Pete.
Okay, cool. Could someone make sure that we get the Jabber logs into the minutes too? Because like I'd like to go back and look at those.
So hopefully an easy question. The last time I coded on a Mac was way before network.framework. Do we know what the uptake for either network.framework or Python, the Python implementation are? Are people actually using it?
Calling Tommy Pauly to the microphone.
Hello. Yeah. So as Brian mentioned, we released it initially in 2018. So we've essentially had 2 years of people adopting. For the first year, people generally don't kind of jump on board initially. But I would say like in the past year, just based on the number of like developer forums, bugs and stuff, and app developers we're working with, we're seeing a pretty good uptake on it. Largely, a lot of developers had been using some third-party libraries. There's like things called like Cocoa Async IO that were really just trying to offer better like asynchronous semantics, but with a socket abstraction, and not necessarily giving you all of these kind of transport properties. And I think we are definitely seeing a shift away from that. And caveat on that most apps are still using like web loading type APIs for a lot of people. But the ones who are doing kind of low level networking, a lot of our like VPN apps, streaming apps, they are using this. And actually there are places, certain platforms like watch apps, as well as we have like app clip apps that are only allowed to use this API, that they can't actually access sockets anymore. So we're kind of
And
pushing.
if you're
things.
allowed to answer if you're allowed to answer the question, is Apple using it internally for like Safari and things?
Yeah, absolutely. This is the layer that is below all of the HTTP APIs and WebKit stuff that we expose, including what we do for all of our connections. So the vast majority of connections on iOS and macOS devices are using this as their way to decide how to bring up the transport. One kind of detail I'll note is the API for the connection is really closely aligned with what we had in 2018 in TAPS. There are definitely additional properties and tweaks that have gone on in the document since then. I expect that kind of once we have like RFC version, there will be some work to spruce up some of the APIs to align them more and make sure that there's going to be like a more accessible cross-platform common approach we can do.
Cool.
Spencer.
Yeah, I just wanted to thank Martin for putting this on. I have not been able to follow TAPS as closely as I would like since stepping down as an AD, and I'm really glad to see the progress has continued. I know that when we were talking about a couple topics in the quick working group, I invoked the word TAPS, and everybody kind of with TAPS. So I think that you did exactly the right thing at exactly the right time. Thank you.
Thanks, Spencer. So I'm in the queue just to say, like, one thing that I am excited about with this in particular is I think it's just coming at a super opportune time with Quick. We are already essentially going to ask application developers to crack open their code and like rework their API, rework the API that they're exercising to move from sockets to something with Quick. And if they're already doing that, what a great time to say, here's something you can use that is going to be in theory portable to lots of platforms. So I think it's sort of like it's kind of a chance to get two wins here with bringing in Quick and bringing in abstraction simultaneously.
So that's actually one of the things that is driving us to get this done. We thought we were about 80% done about 2 years ago. And then we had a bit of a lull in the working group because almost everyone who was working on this either ran out of funding or changed jobs or both. So there was like a 9 months kind of, you can actually see it in the GitHub. There's this right. And then, this is one of the things that energized us to sort of, get this thing done. I will say that one of the questions that we ask ourselves often, sort of like a litmus test for a change to this API is we want to make sure, one, that it would be a good API to put on top of Quick. Now, pointedly, 8095, the original study that we did not consider Quick because at the time, the charter guidance was we're only going to consider published IETF protocols, and Quick had just chartered, right? So there's a little bit of a race condition there. But one of the litmus tests we use when we're evaluating the API as we make a change to it is, does it make sense as an API between H3 and Quick? And does it make sense as an API for some sort of stream like Mask on top of H3, on top of Quick, right? And it has to be able to work as both, right? Like you have to either, have the interface be, you'd want to be able to implement a TAPS on top of a TAPS, right? So that might not be in terms of like code size the best thing to do, but as an abstraction, if the abstract API doesn't support that, then that's a pretty good test that we need to think harder about the abstract API.
Jana.
Brian. I basically wanted to ask two questions. One of them is, do we have evidence of other folks besides Apple? And then I'm saying besides Apple because I know that Tommy and the Apple folks have been involved in the progression of the TAPS working group and the document itself. So there's no doubt influence that's gone both ways, and the TAPS interface has benefited tremendously from having that implementation experience. But have you had success with others adopting the API besides Apple? And the second part of this is, it's with relation to Quick at least. one of the things that I found is that people are building these libraries have a particular API philosophy and a particular API model. And with H2O, I can say that, for example, H2O has a particular model and quickly sort of fits into that model that H2O has. It's separable from the HTTP3 implementation, but it definitely has the flavor of the API that H2O itself has. So I think that that same sort of thing applies to a lot of other libraries, which I see actually as a feature, right? And that's a concrete API, not an abstract one. But so do you see the value in keeping the abstract API as simply functional rather than trying to make it aspirational for quick implementations to try and build themselves to that API?
So there's 3 questions there. I'll answer the first one first. I am aware of groups that are working on future APIs that are watching TAPS with great interest. I can't talk very much about them. I am also aware of groups that are maintaining existing APIs who have looked at TAPS and said, this is not for me. Mainly because if you have an enormous installed base of people who are all writing to that API and that API's shape is fundamentally different than TAPS, then there is no reason to migrate them. The second question is about sort of like the impedance matching between the current concrete APIs for something like Quick and the abstract API in TAPS. And I would say that the first aim of this work is making sure that we move toward the rough shape of TAPS. And the rough shape of TAPS is more asynchronous, which I think a lot of these H2 APIs are because you have the multi-streaming, and less imperative, which a lot of the H2 APIs have because it's like, go connect to this web page and go do the, right? Like, so if we can get to the point where the application is less involved in the details of the life cycle of the connection, that's a win no matter what. That's sort of like, that's TAPS level 0 of, at least moving the shape so that you can start to build applications that have that interaction model. With respect to sort of like H2 and H3 over TAPS, we have a lot of discussion about the priority model in TAPS and sort of like how priorities layer in TAPS. And we tried a little bit to keep that up with the developments in H3, but then we kind of gave up, right? Like, so the deeper you get into the concrete choices we made in TAPS, the farther you're going to diverge from like sort of full parity. I see Martin.
Finish your thought. But I have two things to say after you've.
I think that's actually the finished thought.
Okay, great. So one, a comment on the space. So the WASM community, this is WebAssembly, platform independent programming language, you could say. That's not a good term, but anyway. So the WASM community, as we speak, is flailing around for a networking interface that is platform independent for them to use. And I dabble there. I would not say I understand it very well, but I've kind of suggested, hey, TAPS, but I've done a very poor job because I'm still a TAPS newbie. If there are any TAPS evangelists out there, you might be able to kind of shove something fairly important in that direction. The other thing I wanted to say was that we have about 12 minutes remaining in this meeting. I love this TAPS discussion, so let's keep it going. But if you have any open mic type issues that have nothing to do with TAPS, feel free to enter the queue now. John, are you done? Yes. David.
Hi again. David Skenazy. So I maintain ChroNet, which is the Chrome networking library packaged as a library. So I'd say it's one of the most widely deployed networking libraries out there. So it's responsible for, let's say, the YouTube app, Google search app, and stuff like this. So a good chunk of the internet traffic at large. And we haven't really been like looking at TAPS per se. I mean, just in part because this was like library was created like before TAPS. But let's say that hypothetically we had an effort to rebuild said API. My main question, Brian, is like TAPS is nice that it kind of unified the terminology. And so having, worked on network framework at Apple and now on Cronet at Google, it's been interesting to see how like there are many different ways of doing the same thing. And so having kind of a bit more consistent naming is useful. But I'm still trying to figure out why should I get more involved in TAPS? Like, what does it get me? Because like you said, the IETF doesn't want to be prescriptive about programming languages, but and I totally agree with that. But when you look at kind of into the details of any networking API, you really get caught into the details of your programming language. Your threading model is a huge one that I've seen be problems. Like if you try to, something I've tried to do several times is like interfacing two different networking stacks together.
Yep.
And if they have different models, it's just a nightmare. And so, like, none of these are answered here. So what is the point of having a unified concept if, and I see Tommy coming behind me in the queue, what is the point of having a unified concept if you're never going to be able to align all these things?
So, okay, so Tommy and I are going to tag team you now. I'll point back to my answer. So first of all, I'll point back to my answer to Jana. It's more important for me personally that these things have congruent shapes as opposed, like first is congruent shapes, right? Like, so it's asynchronous. We're not doing this thing where we like send UDP packets directly to a DNS server because we need to know the naming. It is, it is event driven according to the prescriptions of the threading model that you're working with. I will say that like PostSockets specifically tried to define a threading model to unify all threading models, which was a great research project that we threw on the floor because it was like, right? Like we can't even get this to work in different versions of Go. So the second thing would be like is a little bit of terminology unification goes a long way. What I would like to have, like the advantage for Cronet here, great name by the way, would be a lot of sort of the mobile app development space right now is people writing to sort of multi-platform frameworks, and those multi-platform frameworks need to support the lowest common denominator so they can implement on top of everything. If Cronet has an API shape that looks a lot like Apple's network.framework API shape, then these like sort of like libraries can become relatively thin layers and you get maximum performance on both platforms, right? There are fewer arguments to make in this case, sort of on the server side of things, because there you actually do want to be able to reach further down, and we have facilities in TAPS to say, you know what, I actually know what the hell I'm doing. I want to reach all the way through the abstraction and tweak that parameter right there. I think you've identified the threading model thing is the scariest one, and the main reason not to do this in a platform and programming language independent way. Like it would be interesting if we had the energy to evangelize that out in the programming language standardization committees, but I don't think that that's going to return on investment in the next decade.
Yeah. No, I totally agree, because like what you were saying about having kind of this common layer that's on top, I've seen this kind of like, let's say if you wanted to build something that's, a fork that can either do Cronet or network.framework, because for example, Cronet works on iOS. The problem is those two have very different threading models. And so then you're stuck with a fork that cannot possibly be efficient because it's bridging between them. And I've had the same problem on the bottom where Tommy keeps asking me to implement Cronet over network.framework. And so the idea would be to have like the Chrome quick stack and the network.framework UDP stack. But again, that's not possible because of the threading model mismatch. So for me, that's really the deal breaker.
Yeah. David, could we take this offline? I'd like to actually have an
that's
hour.
Probably a good idea.
I'd like to have an hour in front of a virtual whiteboard with you on this, because I think that would be super useful for both of us.
That'd be super interesting. Yeah,
I think that's what Martin's going to tell us to do. It's like, hey, Google, go talk to yourselves on Google Time.
Okay, yeah. So Tommy may have a response to that, but I'll let him do it in his Q section. So Spencer, go ahead.
Open mic. If Tommy is following up on that, please go ahead.
I think we just go ahead, Spencer.
Let's see. Okay. I just wanted to mention this to the transport community at large. We had talked about in whatever the last IETF we were in Singapore during TSV area. Ted Hardy and a couple of people, I'm thinking at least a couple of other people and me were talking about a quick dispatch function. I know I've talked to the ADs about that fairly recently just to see if that seemed like a good idea. I just wanted to let people know we did talk about that and we thought it was a good idea in the past. And as Quick gets closer to a significant recharter event, not just the one that they've just done, I think that there's going to be more need for that to make sure that things aren't wandering off to an area and stuff like that. That basically that people can get feedback from the community on things they're proposing in a reasonable way. And if that could happen without distracting the Quick working group, that would be awesome. Thanks.
Thank you, Spencer. I'm closing the queue, and Tommy, you have the last word.
All right, thank you. I actually had been in queue earlier to respond to Jonna, and then my Wi-Fi died, and I had to jump back on Mute Echo, so I lost my queue spot. So first, Jonna had kind of asked about other efforts. One other place that this has at least been discussed in that I think is an interesting application of TAPS is in the C++ standard library discussions. They've had some proposals to do new networking libraries. In general, like they wanted like, what is sockets for C++ officially that are async? And the original proposal there was essentially just do a socket with some C++ wrappers on top. And there has been a lot of discussion about kind of using a more TAPS-like interface there. And that's a case where kind of having this generic interface, because it's going to definitely be cross-platform and plan to live kind of longer than our actual trends and transport protocols have lived. It makes it valuable to do TAPS. To David's point, it's one of the other points I wanted to bring up is that we are through TAPS trying to avoid, ossification of the stack through what the apps are doing, either because they can't adopt a new protocol or because they're not able to have the system do cool new features underneath their APIs. I mean, this, such as like proxying over mask. And actually, you're a mask enthusiast, and we're about to have the mask meeting, and it's actually a really interesting case because that's a case in which someone is writing what they think may be a TCP API contract. They're just using a socket, but in fact, maybe the system is actually putting them over multiple quick streams, and maybe it's not end to end, but it's actually going to a proxy instead. And that's a case where when apps have adopted something that's like TAPS, like when people are using network framework, we can do stuff like that very, very easily. Whereas if people are opening up sockets, they've connected to a specific IP address, they're expecting specific TCP options on the socket, that breaks, or you have to do a lot more emulation or mucky stuff to get it to work if you just want to say, hey, let's put everything over mask. So I think that's one of the angles where it's not just about like, how do we enable SCTP? There are going to be other things in which we're changing the first hop transports because we're doing things like proxying.
Okay, I believe that concludes this meeting. The queue is empty. So thank you all for joining. Brian, that was wonderful. I like the discussion, and I think we may have generated some enthusiasm, which was the point.
Yeah. Thanks a lot. Thanks a lot for pushing me to do it. So
it was delightful. So we will see you all. And do you have anything else, Magnus? Before
yeah, I would like to give a short response to, I think, to Spencer about quick dispatch. I think that's something we're going to continue to consider how we do that dispatching function, etc. I mean, I think part of why we haven't done so much or actually got it in place was that we haven't seen super much activity, etc. But it's, as you say, it might be more relevant when we take the next steps and Quick goes into maintenance, a bit more maintenance mode and considering extensions, etc. And then we will have this aspect. And we're also seeing maybe some more pickup of saying people doing mapping specifications, etc. using Quick. So it's going to be interesting to see. But
I know that you all will do the right thing.
well, maybe I just pumped this to some future AD.
Okay, we will see you all in not Prague. Have a good 4 months.